Hi guys, welcome back to my channel. So in this lesson, I'm going to take you through solution to differential equation. A solution to a differential equation on an interval alpha less than t less than beta is any function y of t which satisfies the equation in the question on the interval. So I said it again. A solution to a differential equation on an interval alpha less than beta alpha less than t less than beta is any function y of t which satisfies the differential equation in question on the interval. So in this lesson, I'm going to show you how you can verify if a function given is a solution to a differential equation. Without talking so much, I have an example here for us to go through so you understand what I'm saying. So it says show that the function y of x is equal to s to the power negative 3 out of 2 is a function to the differential equation 4x squared y prime prime, that's the second derivative, plus 12x y prime plus 3y is equal to 0 for the interval s is greater than 0. So what this is trying to say is whenever you want to find a solution to any differential equation, first of all, you should know the interval with which your differential equation is valid. So we call that interval of validity. So you'll be given an interval, and within that interval, you are supposed to determine the function y of t, which will satisfy your differential equation. Considering the problem we have here, we've already been given the function, which is y of x is equal to x to the power negative 3 out of 2. So we have to determine if this is indeed the solution to this differential equation on the interval x is greater than 0. So let's see how to solve this problem. So to solve this problem, differential equation simply means wherever we see y prime prime, we need to make substitution. Wherever we see y, we need to make substitution. So first of all, the function is y of x is equal to x to the power negative 3 out of 2. You can see y prime here, meaning we need to find our y prime, which is the first derivative of this function. First derivative of this function simply, that's a basic differentiation. So you're going to have negative 3 out of 2 multiplying x, then you subtract 1 from the power. So deducting 1 from here, you're going to have negative 5 on 2. Then we find our y prime prime. And that is going to be the second derivative of this, or you say the first derivative of the first derivative. So see, you want to find y prime prime, meaning that we are going to differentiate our function y of x two times, right? We've already differentiated to get y prime. So the next thing is you're going to differentiate this again to get y prime prime. So to do that, you're going to multiply the power negative 5 out of 2 by the whole thing. That will give me 15 out of 4 multiplying x. Now the power is negative 5 over 2. I'm going to deduct 1 from it, so I'm going to have negative 7 out of 2. So now I have my y prime, I have my y prime prime. I only have to do substitution. To do that, I'll go back to my equation. I have 4x squared. Then I have y prime prime. Wherever I see that, I make substitution. 15 out of 4 x to the power negative 7 out of 2 plus 12x, then my y prime comes here. My y prime is negative 3 out of 2, x to the power negative 5 out of 2, right? Plus 3y, but the y is given as x to the power negative 3 out of 2 should be equal to 0. So we have to solve for the left hand side so that we get equal to 0. So 4 cancel this 4 and I'll be left with 15, right? Now I have the power of x here to be 2, the power of x here to be negative 7 out of 2. So I'm going to have 2 minus 7 out of 2, 2 minus 7 out of 2, and that is going to give us 4 minus 7, so negative 3 out of 2, right? So we're going to have 15 multiplying x to the power negative 3 out of 2. Plus, we come here, 2 goes into itself 1, cancel here 6, right? Now, negative 3 is here, negative 3 times 6, that's going to give me negative 18, right? Negative 18. Now, x, the power of x here is 1, the power of x here is negative 5 out of 2. So, you're going to have 1 minus 5 out of 2, and that's going to give us negative 3 out of 2 as well. So negative 3 out of 2. Then finally I have plus 3 x to the power negative 3 out of 2 is equal to 0. You can clearly see that I have 3x to the power negative 3 out of 2 here. I have 15x to the power negative 3 out of 2. I can add them. So I'll have 18x to the power negative 3 out of 2 minus 18x to the power negative 3 out of 2 is equal to 0. So when I subtract this, I'm getting 0 equals 0. Therefore, it is a solution to our problem. That is it. So therefore, y of x, which is equal to x to the power negative 3 out of 2, is a solution to our differential equation. Thank you for being with me and hope joining me in the subsequent classes of our differential equation series. Don't forget to subscribe. If you like, then you share.